Have you ever looked up at the night sky, at that vast, star-dusted tapestry, and felt a sense of profound connection, a feeling that you are part of something immense, something ancient? In that cosmic ocean, our Earth is a tiny, fragile mote of dust. It's our home, the only one we've ever known, and it has nurtured life for billions of years. But you know, like all things in the universe, it won't last forever. The story of life on Earth must eventually have a final chapter. The question that has haunted philosophers, poets, and scientists for centuries is not if it will end, but how. The universe is a dynamic and sometimes violent place. The very forces that created our world could one day unmake it. Scientists, by piecing together clues from the cosmos and from our own planet's deep history, have envisioned several possible scenarios for Earth's ultimate fate. These aren't just fanciful tales of doom. They are plausible futures grounded in the laws of physics, chemistry, and biology. They range from sudden, catastrophic events from the depths of space to slow, inexorable changes driven by our own star or even our own actions. So, let's embark on a journey, not through space, but through time, into the deep future. Let's explore the scientific theories about how life on our beautiful blue marble might end. This exploration isn't meant to inspire fear, but rather a deeper appreciation for the precious, fleeting moment of existence we all share. Come with me as we peer into the possible ends of our world. Imagine our solar system, not as the clockwork mechanism we often picture, but as a cosmic shooting gallery. For billions of years, Earth has been moving through this gallery, and it has been hit before. Most famously, about 66 million years ago, an asteroid the size of a mountain slammed into the Yucatan Peninsula. The impact was cataclysmic, unleashing energy equivalent to billions of nuclear bombs. It triggered global firestorms, colossal tsunamis, and plunged the world into a nuclear winter that choked the sunlight from the sky. The reign of the dinosaurs, which had lasted for over 150 million years, ended in a geological blink of an eye. Could it happen again? Absolutely. Our solar system is still littered with debris left over from its formation, asteroids and comets of all sizes. Astronomers are constantly scanning the skies, cataloging what we call near-Earth objects, or NEOs. We've found thousands, but we know there are many more lurking in the darkness, their orbits occasionally crossing paths with our own. An object just a few kilometers wide would be enough to cause a global catastrophe, wiping out agriculture and collapsing civilization, if not extinguishing humanity entirely. The good news is that we are not as helpless as the dinosaurs. We have telescopes, we have mathematics, we have the ingenuity to track these potential threats. Missions like NASA's DART experiment have proven that we can, in principle, alter the course of an asteroid. It's a race against time and cosmic chance. We are the first species on Earth that has the ability to look up and defend itself from a celestial hammer blow. The question is, will we be wise enough to use that knowledge before it's too late? The threats to life on Earth don't all come from the sky. Some of the most potent forces of destruction lie dormant right here, deep within our planet's crust. We live on a thin, brittle shell floating atop a sea of molten rock. Occasionally, this subterranean fire finds a way to the surface in the form of a volcano. But we're not talking about your typical eruption. We're talking about a supervolcano, an eruption on a scale that is almost impossible to comprehend. An event that could tear a continent apart and alter the course of life on a global scale. There are several of these geological time bombs scattered across the globe, like the one slumbering beneath Yellowstone National Park. An eruption from such a caldera would not just spew lava, it would eject hundreds, perhaps thousands of cubic kilometers of ash and sulfur dioxide into the stratosphere. This massive plume would encircle the globe, creating a volcanic winter that could last for years, even decades. Sunlight would be blocked, global temperatures would plummet, and acid rain would poison the land and water. The consequences for life would be devastating. Photosynthesis would grind to a halt, causing a collapse of the food chain from the bottom up. Crops would fail worldwide, leading to mass starvation. The last known super eruption, the Toba event in Indonesia about 74,000 years ago, is thought by some scientists to have pushed early humanity to the very brink of extinction. While these eruptions are exceedingly rare, happening on timescales of hundreds of thousands of years, They are a stark reminder that our planet's interior is a place of immense and untamable power. Let us now cast our gaze much farther out, beyond our solar system, to the most violent and energetic events known to occur in the universe, gamma-ray bursts, or GRBs. These are not mere explosions, they are the death cries of massive stars collapsing into black holes, or the collision of two ultra-dense neutron stars. In a matter of seconds, a GRB can release more energy than our sun will produce in its entire 10 billion-year lifetime. It's a focused, narrow beam of high-energy radiation, a cosmic death ray, traveling across the cosmos at the speed of light. If Earth were to find itself in the path of one of these beams, the consequences would be dire, even from thousands of light years away. We wouldn't see it coming. One moment, the sky would be normal. The next, it would be bathed in an invisible, deadly torrent of gamma rays. The radiation would be so intense that it would chemically alter our atmosphere. It would rip apart nitrogen and oxygen molecules, destroying our precious ozone layer, the shield that protects all life on the surface from the sun's harmful ultraviolet radiation. Without the ozone layer, the sun's UV rays would scorch the Earth's surface, sterilizing the land and the upper layers of the oceans. Phytoplankton, the foundation of the marine food web, would be wiped out. The chemical reactions in the atmosphere would also create a thick reddish-brown smog of nitrogen dioxide, blocking sunlight and triggering a rapid, deep global cooling. A gamma-ray burst would be a 1-2 punch, a blast of deadly radiation followed by a devastating climate shift, leading to a mass extinction of unparalleled speed and severity. All the threats we've discussed so far are matters of chance. A stray asteroid, a geological burp, a cosmic stray bullet. But there is one end that is not a possibility, but a certainty. It is written into the life story of the very star that gives us life, our sun. Like all stars, the sun is a nuclear furnace fusing hydrogen into helium in its core. But its fuel is finite. In about 5 billion years, the hydrogen in its core will run out. And when it does, the sun will begin its own death throes and it will take the inner solar system with it. As the core contracts and heats up, the sun's outer layers will begin to expand dramatically. It will swell into a red giant, its diameter growing 100-fold, perhaps more. Its color will shift from a life-giving yellow-white to a fiery, menacing red. Mercury and Venus will be the first to be consumed, vaporized by the star's expanding atmosphere. Earth's fate hangs in the balance. It may be engulfed entirely, or it may be left as a charred, lifeless cinder on the very edge of the bloated star. But long before that final fiery embrace, life on Earth will have already ceased. As the sun begins its expansion, its luminosity will increase. Over the next billion years or so, this slow but relentless brightening will trigger a runaway greenhouse effect on Earth. The oceans will boil away, the atmosphere will be stripped into space, and the surface of our planet will become a molten slag, hotter than a pizza oven. Our blue marble will be transformed into a sterile, scorched rock. This is the ultimate unavoidable end for our world, dictated by the unyielding laws of stellar evolution. Perhaps the most unsettling scenario is one that doesn't require a cosmic cataclysm or the passage of billions of years. It's a possibility that lies not in the stars or in the Earth's core, but within ourselves. We, Homo sapiens, with our large brains and opposable thumbs, have become a geological force in our own right. We are now the single greatest driver of change on this planet. And it's entirely possible that we could engineer our own demise and take countless other species with us. The evidence is all around us. Our industrial civilization, powered by burning fossil fuels, is altering the chemistry of our atmosphere and oceans at an unprecedented rate. This is causing our climate to change, leading to more extreme weather, rising sea levels, and collapsing ecosystems. If left unchecked, this trajectory could render large parts of our planet uninhabitable, leading to societal collapse from famine, resource wars, and mass migration. This is a slow-motion catastrophe, an extinction of our own making. And then there is the faster, more deliberate path to self-destruction, nuclear war. For decades, we have possessed the power to obliterate our civilization in a matter of hours. A full-scale nuclear exchange would not only cause unimaginable death and destruction in the initial blasts, but it would also trigger a nuclear winter. The soot and dust kicked into the atmosphere would block the sun, causing temperatures to plummet and agriculture to fail globally. In our quest for security, we created the very tools that could ensure our ultimate insecurity. Of all the possible ends, this one is unique because it is entirely up to us to prevent it. We've journeyed through fire and ice, from the deep earth to the distant cosmos, exploring the many ways our world could end. An asteroid from the blackness of space, a supervolcano from the fire beneath our feet, a blast of radiation from a dying star, the inevitable expansion of our own sun, or the tragic consequences of our own actions. These scenarios can seem overwhelming, even frightening, but it's important to place them in their proper context. Most are governed by cosmic timescales, unlikely to happen for millions or even billions of years. The true value of this cosmic perspective is not to dwell on an uncertain, distant doom, but to illuminate the profound preciousness of the here and now. Life on Earth, in all its staggering diversity and complexity, is a remarkable and perhaps exceedingly rare phenomenon. We exist in a fleeting, gentle season for our planet, a temporary paradise between cosmic catastrophes. Knowing how fragile this all is should not lead to despair, but to a deeper sense of wonder and responsibility. We are the stewards of this world, the conscious part of the universe that can appreciate its own beauty. Let this knowledge inspire us. Let it move us to look after our planet, to protect its delicate biosphere, and to work together to solve the challenges we face. We have one home, this pale blue dot. Let's appreciate it. Let's protect it. Let's cherish our brief but glorious moment in the sun.